welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. It's still building the MachOCodeGen class. So last session we did implement, I think we got a good state where we at least have all the names for all pure virtual functions. So that is very good. But we don't have this record for all the functions. The question is, how do we want to do that? What we can do is, since after this step, we have all names in place, right? But then what we can do is we can check. Yeah, yeah. That's a good idea, I think. Let me see. Okay, so before we continue, let's do process. Let's call this process process vtables 1. Process vtables 1, and then we make a second function. Well, let's call it process vtables process primary and secondary vtables. Okay, and then we create a new class function and call it process primary vtables. Process full primary vtables. Then we say this, so this class, I don't know if we should do it all in one function. Maybe multiple passes are easier to maintain. So here we say this function goes through all vtables and fills names for pure virtual functions. And fills. This goes through all vtables and base classes and fills names for all pure virtual functions that are overridden. I make here, line break. Okay. And then we make another function. This information we probably put somewhere else here. Primary vtable. Vtable, it's primary vtable. Vtable, I don't know where to put it. Maybe you just put it here. Primary vtable order overrides of base class at offset 0. New virtual functions. But this is not always the case. This was not always true. So this is actually wrong. Let's remove this information then. If it's wrong, it's useless information. Okay. So with this code, let's have a new, let's make a new loop here. We don't delete the comments yet, just in case we need any of the stuff. Actually, I first want everything implemented, everything working, and then I will delete all the commented code. This is also just for tests. Test begin, test end, will be deleted. Okay, so process primary vtables, full primary vtables, class type. And so what I'm thinking we do is how about we call this process all vtable hierarchies. And then we create a new function, process primary vtables. Process white vtables. There we go. Okay. And we say class type. So what do we need? Vtable base class. If it doesn't have a base class, do we care? No. If it doesn't have a vtable, we also don't care. So the conditions are the same. Of the yeah. And then here we say if we only care about the first vtable, the primary one. Yeah. So we say vtable. Copy this. Vtable equals vtables 0. Or I think we can also use front, no? Front. Yeah. I think we can also use front here. And then we front. front. Base class, get base class, get, so this one, base, yeah, base class, front. So I think we use the same condition here. Front, base class, vtable offset, front, base class, yeah, and then here we do a return, base class type, can move this together, base class vtables empty, return, okay, and then we also use this, okay. Okay, and then we expect assert. What do we expect? Combined count. Combined count. So we expect that I think we expect that assert vtable offset is 0 likely, I think, and this, and then we expect, I mean, it's very similar to what we're doing here. Maybe we should put it in one function. Maybe we can put it in here. Process primary tables. Let's see. Actually, hold on. No, this is not right. We need to loop all base classes, no? Base class. vtable. I think we need to, so we only use a base class, but we loop base. Yeah, we take we take for base class base class class type dot base classes, yeah, and then base class, yeah, and then so we try to find base class vtable, yeah, okay, and I think we move this in here, base class dot. Okay, and then we iterate this base base base. Okay, then we remove this. Okay, and then we vtable index. What do we do? We create a vtable index and a base vtable index. Base vtable index. Okay. And so we say base vtable. Remove this base vtable index. Base vtable index. So we say if if oh, I'm not sure what to do here. vtable index is detour. So we want to skip detours. All detours should be skipped because they have no, they should not be skipped. What do they? Wait. We need to if if man, we need to the naive algorithm would be we take every entry function and then we loop through all things and compare compare it. But that sounds a bit expensive. It should be simpler, no? Base class. It seems a bit expensive. Entry. So the entry, where does it begin? It should be in order. No? Yeah. It should be in order. Okay, so here at the end, make function name. Find function name. Find function name. Begin parse, parse. Is this used anywhere else? No. Why don't we return a return why don't we return a string view here? Can't we have a std string view here? Return name return name dot sub str I plus 1. Then we rename this to find function name. Find function name. Function name. There we go. And just like that, the whole thing is a lot simpler. Then we can reuse this function here, and we say we say find function name entry dot mname base entry dot name. So this is std string view entry function name const base entry function name. And so if this equals this, then is override is implicit. If not, starts with yeah, so we have this check, and then inside this check there would be this check, if I'm not mistaken. So if these functions are the same, then we check this, and then it's an override, otherwise it's implicit. I think this is correct. Well, we need to check. Okay, what about the destructors? Starts with maybe I would say if is detour and basis detour, or this other thing. Could that be? I'm not sure about the condition here. Well, we can step inside and see what's going on, I guess. I'm a bit suspicious. It's probably wrong. It's probably wrong. So vtable count. So we have destructors is detour, yeah. Okay, what we forgot to do is plus plus. If none of these things is true, so here we would say this plus plus and this plus plus, right? And otherwise, if that is not true, then we would, what would we do then? Then we would just increase this one. Is that possible? Maybe. Maybe. Let's put a breakpoint here, here, yeah. So entry, there we go, is detour overwritable. So the names, they won't match, but they are both detours. So we go in here and it is an overwrite. It is an overwrite then. It's not a pure virtual, and it is an overwrite. Yeah. Yeah. And then we increase both and go to the next one. Okay. Then same story, override. Okay. Okay. Well, let's try to find some more complicated science info. Two, 3. Let's look for some more complicated one. Let's go with update module if class type dot mname equals update module, and let's also do int a 0, and let's do another for object module. There we go. Aha. Okay. Entries. Okay. Oh. Okay, well, there's some logic error. Why? Okay. Update body. What are we looking for here? Number 6. Number 6. Get previous health. Did we not find that? Get previous health. Get. Oof. So much. Holy shit. Here, get previous health. It's there. Why did it not find it? Get previous health. Const. Get previous health. Get previous health. Get previous health. It somehow did not find it. That's strange. Which class is this? Body module. Well, then let's do a body module. A body module. So many modules. The modules say have crazy inheritance, so that's why. There we get the most bang for the buck. Well. Yeah. Okay. Name body module. So, what do we have here? Entries. So, 0 base entry. Behavior module. Detour. Okay. Override. Okay. Entry is override. It's already set to override. That's okay. So is detour true? All right. Next. So here we have get module name key. Get module name key. So the names are identical. It's implicit because body module body because it is a pure virtual, right? Pure virtual. It's implicit. Yeah. It's implicit. Okay. Okay. On object created. Okay. On object created. On object created. Yeah. There we go. Okay. 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 So far so good. Now number 5, entry preload assets, and there we go. Okay, next number 8. Now we have our candidate on delete, module on delete. They look the same to me. Looks good to me. On delete looks okay. And it is okay. Well, what's the problem here? base class. Maybe it's because we have two base classes. Not sure. And this seems to be fine so far. Everything is going smooth. Very, very smooth. So where's it hanging then? How about we put a breakpoint here? So this is now the second base class. Second base class. So body module. Attempt damage. Okay, so vtable. So it will start here. Attempt damage. Get initial health. Get previous health. Get previous health. Get. It's here. Get previous health. 53. Oh, let's okay. Let's step here. So what do we have? We have this and this. Vtable index. Okay, this seems to be fine. Vtable index. I think we could also move vtable index out of here. I think. Yeah. True, 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 false. Body module. Vtable index. Okay, let's step a bit here. Yeah. Let's put a breakpoint here because it does hit here once, right? Yeah. So we are at 48. 48 is implicit. Okay, now we increase both vtable index and this one. Okay, good. So now we have attempt healing. Attempt healing. They look they look the same. Is detour? No. Function attempt healing. Attempt healing. Yeah, okay, it's implicit. Good. So far, so good. Entry. Estimate damage. Estimate damage. Yeah. They are the same. Good. Next. Get health. Get health. Const. Looks good. Is implicit. Okay. Get max health. Get max health. Is override. Because body module, body module. Entry. Get previous health. Okay. Get previous health. Get initial health. Oh. 5, 53. 5, 53. Get initial health. Get previous health. 53. 53. 53. 53. Get previous health. Yeah. And here we are. Number 5. Number 5. Number 5. Get initial health. Okay. So we have a function here that doesn't show on the other side. Get initial health. Yeah, so initial health is not showing up in there. So I won't find it. So it's not an override. How do we deal with this? How do we deal? Get previous health. How do we deal with this situation? I mean, we can... So basically, there's two choices, counting one side or the other side up. Counting one side or the other. Maybe... We need to, I think we need to test both sides. So if we reach a position where this is false, this condition, then we need to search both sides. Try search both sides. Right? I think so, yeah. Okay, how do we implement that? Okay, I think the first thing we can do is move this out, I think. Yeah. Then we move this, we leave this here. Then yeah, there should be a way to implement this by walking both sides of the aisles. Yeah. So right now we only walk one side here, but we need to take a snapshot of the position. take a snapshot. Yeah. How do we implement this? What we can also do here is make it a while loop. Oh, I don't have a good idea right now, but it should be possible to reuse this and walk once with this and once with this. But then it needs to reset to the first time it has failed here when it walks a second time, right? And then only if both walks have failed, then what do we do then? Then, well, that's a good question. If both walks have failed, what then? Switch on. What's the time? Almost 1 hour. I think I will stop it here. Let's do it next session. Yeah, I don't know right now what the best way to implement this is, but I have a rough idea. We need to walk both aisles because we need to do this here because we skip, like there will be some new virtual functions that are not in the base class virtual table, right? So this one is necessary, but we also need the other way around because the parent class can also miss some functions from the base class for some reason, right? By the way, we also still want to build a relationship between the pure virtual function, between the virtual functions and the bottommost base class that we also still need. Okay, but we can worry about this after we have implemented this one, I guess. Oh man, it's so complicated. At least we got the pure virtuals. That's a progress. Yeah. Good. So what if we search both sides and we don't find? What do we do then? Then I don't know. Then we increase this one, I think, by 1. or we increase, then we increment both. The last step, when both sides failed, then we increment both. Yeah, because they have both failed. Yeah. Yeah, I think that's correct. Yeah. So if we hit this, we somehow need to start a search where we search both sides until the very end. And if both fail, then we increase both at the snapshot where it's the first time it failed, and then we repeat and go on. And then it keeps doing that. I wonder if there's a simpler way. A simpler way. Maybe. Yeah, there's always a simpler way. Yeah. Shit. If you start search on one side. No, I think that's the right approach. Yeah. I think that's the right approach. Okay, we just need to find a good way to implement this. Yeah. Good, but I don't want to do it now. We do it next session. Maybe I add a comment here to do walk both aisles until the end, then increment both if both aisles failed. Search. Yeah. That's it. Good, and I will take a break here. And I wish you a great day or night. Until next time, goodbye.